An 8x6 sheet. One corner folds exactly onto the opposite corner. So, how long must the crease be? PQRS is a rectangle, with PQ equal 8 and QR 6. The sheet is folded so Q lands exactly on S. So which option from these gives the exact length of this crease? Two things determine the fold: position and angle. First, slide a crease a fixed angle. Away from the middle, the folded image of Q misses S. Only one position reaches it. But the angle matters too. Hold the middle point fixed. A shallow crease folds Q above S, whilst a steep crease will fold it beneath. Only the middle angle lands exactly on S. Now take any point X on this successful crease. X does not move during the fold, while Q becomes S. So think about doing this. Draw X to Q on a piece of paper. Folding the sheet does not change the length of this line as it moves, and when it's folded, the line from X to Q must exactly overlay that of X to S. Otherwise, the points Q and S would not meet. So XQ and XS are the same rigid length. Let M be where the crease crosses QS. M stays fixed during the fold. So MQ equals MS and M is the midpoint. For any crease point, XQ equals XS while XM is shared between them. The two triangles then have the same three side lengths, so their angles must all be equal. Those angles form a straight line, which is 180 degrees, split equally, so each must be 90 degrees. The crease crosses QS halfway and at 90 degrees. It is the perpendicular bisector, so this is going to determine the line, the crease. Place P at 0, 0. Then Q is 8, 0, R is 8, 6, and S is 0, 6. The points we need are Q and S. Halfway between their coordinates, 8 and 0 is 4. Halfway between their y coordinates, 0 and 6, is 3. So the midpoint is 4, 3. From Q to S, move left 8 and up 6. So this means as we go along 4, we go up 3. Now rotate this movement 90 degrees clockwise. Left 4 and up 3 becomes right 3 and up 4. That is the direction of the crease. Its gradient is 4/3. For every 3 units moved right, rise 4, or for 1 unit, rise 4/3. This also matches the perpendicular gradient rule, that the two gradients must multiply to -1 if they're perpendicular. Let F be the midpoint directly below M on the bottom edge. So F is 4, 0. The crease meets the bottom edge at U. It passes through M, 4, 3, with gradients 4/3. Its line then is just y minus 3 equals 4/3 times x minus 4. It goes through the point 4, 3 and it has gradients 4/3. At the bottom edge, y is 0. So using this, minus 3 equals 4/3 times x minus 4. Therefore, x minus 4 is minus 9/4, so x is 7/4. So U is 7/4, 0, the point. In the right angle triangle MFU, the vertical side MF is 3 and the horizontal base FU is 9/4. Along the rectangle's bottom edge, PU is 7/4, while UF is 9/4. Let T be the point directly above M on the top edge, so T is 4, 6. We can repeat the exact same process as at the other side. To reach the top edge from M, go up 3 and, with the same gradient as we're on the same crease of the same line, means right 9/4. Starting at X equals 4 gives X equals 25/4. So V is 25/4, 6, the point. In right angle triangle MTV, MT is 3 and TV is 9/4. Now place W directly below V on the bottom edge. In the final right triangle, UWV, the horizontal side UW is 25 quarters minus 7 quarters, which is 9 halves. The vertical side WV is just 6. The hypotenuse UV is then the crease of this triangle. In right triangle UVW, the legs are 6 and 9 halves, and UV is the hypotenuse. By Pythagoras then, UV is root 6 squared plus 9 halves squared. That is root of 225 quarters, which is 15 halves. The answer is B.